Now that you know how to evaluate piecewise functions, we want to look at how do we graph piecewise functions. So the first thing I put here under your notes is some examples of pictures of different types of piecewise functions, just to kind of show you what you can expect. So notice that when you have a piecewise function, this particular picture is made up of two pieces. One piece, it looks like, actually no, excuse me, it's made up of three pieces. One piece here is this parabola, and notice that it's the parabola for x values less than, this picture is really small, it looks like x values less than 2. When x is 2, we get another piece, and then when x is greater than 2, we have our third piece. Same thing is kind of happening here on this picture. We have one piece down here with x values less than, looks like -3. Another piece for x values from -3 to, it looks like 1 or 2, maybe somewhere between 1 and 2, and then a third piece once we get larger than that. And then also notice on this example, so on this one here, notice that there were gaps in between each y value. This one here was a very smooth transition. It was not a discontinuous function in the aspect that when x values were less than 1, we had this linear function. And then at that same y value, rather than picking up our pencil and moving, we just transitioned smoothly to a quadratic function. And then it looks like at x values greater than 2, it does again pick up and now move to this other piece. So how do we get those graphs? Well, here are the steps for graphing a piecewise function. The first thing we're going to do is we're going to take our piecewise function, whether it's composed of 2, 3, 4, 5, however many pieces, and we're just going to pick a piece to graph. Once we do that, we're going to evaluate and graph each endpoint determined by my inequality or my interval given. We always want to make sure we use the right circle, open if it's not included, closed if it's or equal to, or when we have brackets or parentheses, so open with parentheses, close with brackets. And then when we have an open interval in the aspect that we do not have two sides to it, so like x less than something or x greater than something, then we want to just do the one end point. We'll use our knowledge of the shapes of the graph shape, or we can plot a bunch of different points, and we'll do that for each piece. So let's look at example 1. So first thing I'm going to do is I'm just going to go ahead and I'm going to take this first piece here. And it says that my graph is 3x plus 4, so I have this linear graph if x is less than -2. So I'm going to plug -2 in and see what I get. So 3 times -2 plus 4 gives me -6 plus 4, which gives me -2. So I'm going to go to the x value of -2, has a y value of -2. I'm going to put an open circle there. My circle's off a little bit, it should be right on the point. But I have an open circle there at -2, -2. And then what I could do from there is I can pick more points. I could see what's happening at -3, what's happening at -4. I don't need to do that because I see this linear equation has a slope of 3. So I can either rise 3 and run 1, or I can go down 3, 1, 2, 3, pretend my graph is longer, back 1. And so this piece of my function is going to look something like this. And I'm going to use an arrow to show that it's all x values less than -2, so it keeps going. And then I'm going to take my next piece. So my next piece says x squared minus 3 if I'm between -2 and 1. So kind of the same thing as I did before. I'm going to start by plugging in -2. So I'm going to have -2 squared minus 3. Well, that gives me 4 minus 3, which is 1. So at -2, now I have an x value of 1. I'm going to use a closed circle this time. And then I'm going to do the same thing at 1. And I have 1 squared minus 3. Well, 1 minus 3 is -2. So at 1, I'm at -2. And here I'm going to have an open circle. And then I could plot some more points, but I can see that this is a parabola because of the -3 outside of the function. I also know it has been shifted down 3 units, so I know that I'm going to have a vertex at -3. So then I connect those in the form of a parabola. Apologize, that's not a very good parabola. But then from there, I just go ahead and I take my last piece. And my last piece says I'm going to have x values equal to 2. Y values equal to 2 no matter what my x value is. So when x is greater than or equal to 1, I get a y value of 2. And like I said, that's just that constant function with all y values being 2. And that is my piecewise function. So let's look at 2 more examples with that. Looking at example 2, I'm going to do the same thing. It doesn't matter where I start. I can pick either any piece I want to start. I usually just start at the top and work my way down. So my first one says when x is greater than -1, I have x squared minus 2. So I'm going to plug -1 into that. -1 squared minus 2 is 1 minus 2, or -1. So when x is -1, so it's very coincidental that I got that this happened on both of them, that my y value was the same as my x value. That typically does not happen. So don't think that that's something that's always going to happen. So when x is -1, y is -1, I want to use an open circle because it's just greater than. And so for all x values greater than -1, I have this parabola. So again, I can plot some more points, but because I know this is a parabola that's been shifted down to, I know I'm going to have a vertex at -2, and I'm going to have a parabola for this piece of my function. And let's see, then from there it tells me that if x is -1, I'm at 2. So at -1, I plot the point 2 with a closed circle, and that's it. There's no other function to follow up with, no other points to plot, because it's just that one point that I want to do. And then I'm told that if x is less than -1, I'm 2x plus 1. So 2 times -1 plus 1 gives me -2 plus 1, which gives me -1 again. So I am again going to put an open circle here at -1, so I'll just trace over my first open circle, and then I can plot another point, but I see it's a linear function with a slope of 2, so I'm going to go down 2 and back 1, and there will be my third piece of my piecewise function. And then looking at the last one, so this is going to be a good one to try on your own, and pause the video, try it, and then make sure you've got it. So again, I'm going to go ahead and hopefully you've had a chance to try it. Start with my top function. I'm going to plug in -2, and I have 1/2 times -2 plus 1. Well, that becomes -1 plus 1, which is just 0. So when, oops, sorry, ignore that little mark I just made with my finger. So when x is -1, y is 0, and I'm going to go ahead and put a closed circle there. And I'm going to use the same function for all x values less than. I went at -1. I meant to do that on -2. I apologize. At -2, y was 0. And so that is one single point. So now every single point, every single x value less than -2 is going to use the same function. So I can plot another point to see what it's going to look like, but since I see that this is a linear function, it'll be a straight line. So I'm going to go down 1 and back 2. Down 1 and back 2, and there will be that piece of my function. And then I'm going to go ahead and graph the middle piece. The middle piece is x cubed plus 3, so I'll plug -2 in to begin with. -2 cubed plus 3 is -8 plus 3, which is -5. So let me extend my graph a little bit here. So when x is -2 with an open circle, I'm at -5. 1, 2, 3, 4, 5. So I should be about right here. And then when x is 1, so I'm going to plug in my other endpoint. 1 cubed plus 3 is 1 plus 3, so 4. 1, 2, 3, 4. And I'm going to use an open circle again. And again, I could plot some more points to see what the heck's happening in there, but I see that this is a cubic function that's been shifted up 3. So I know my vertex is here, and my function's going to look something like this. Okay, and then finally when x is greater than or equal to 1, it's just 0. So again, there's one of those constant functions. So I have a y value of 0 when x is 1. It's closed circle. And then it's a straight line, it looks like. And that's how you graph piecewise functions. So notice I'm just graphing each piece. It's like rather than having one problem, I have 3 mini problems inside of a problem. So the only other thing to look for, and I guess I didn't do an example like this, is every now and then, just like on example 2, these two functions overlapped at that point. Sometimes when you do your first one, your next one, you're going to end up filling it up in the circle that you left open. So that's just something else to be aware of. Other than that, that's graphing piecewise functions.